Welcome to the showcase for Master of Engineering capstone project of Indoor Air Quality Improvement System at UC Irvine from Team XYZ. Imagine a man working at home due to COVID-19 situation. He was energetic and mental clear in the morning. After an hour and an hour and hours of work, the Indoor Air Quality Index is increasing dramatically. This causes the working man to start to feel dizzy, tired, and even headache, which dramatically cuts down efficiency and is very unhealthy. You might want to ask how AQI is related to our health and how to improve our indoor air quality. Well, first we need to clarify the definition of AQI. According to airnow.government, AQI stands for Air Quality Index, which indicates the pollutant level in selected space. It considers the parameters such as the amount of particulate matter that is sized 2.5 microns and 10 microns in width, the oxygen level, and the carbon dioxide level. During the pandemic, people are staying at home much longer. Unlike before, when people could just open the window and leave home, there should be more and more notice on when and how long people should turn on devices such as air humidifier, air purifier, and so on. However, there is no comprehensive platform or apps relating to indoor properties with air quality. With the motivation to develop a better air quality for indoor working space, mechanical engineer and the team lead Sun Xu, mechanical engineer Ze Yuan, and electrical engineer Yu Feng formed Team XYZ at UCI and worked together with Advantech to develop the project of indoor air quality improvement system using Advantech WISE 4012E and MIO 5272 together with different kinds of sensors and microcontrollers to get data to the Azure cloud. The data on the cloud is then analyzed and illustrated back to the customer as a dashboard format with different suggestions and graphs. In short, this project serves as a comprehensive IoT product for customers to improve the indoor environment and to improve their lifestyle. Now, let's dive into the project system flow block diagram. There are three sensors for our system: DHT22 for humidity and temperature, SGP30 for CO2 level, and PMS5003 for PM2.5 level. Raw data is collected and processed by Arduino. Then it sends the data to the WISE 4012E through digital output, and WISE transfers the data to Microsoft Azure through Wi-Fi. Once data is stored in the cloud, JSON Exporter is used to deliver the data to Grafana and uses MIL5272 to illustrate the dashboard in the format of graphs. It also sets thresholds to critical values that trigger alerts and make suggestions for users. Plus, the automation until for window and air purifier opening could be triggered by one click on the dashboard. That triggers relay control with the HTTP patch method at WISE. All components in the block diagram work together and fit into this creative 3D printed shell design where you can get alerted and turn on or off as suggested with any smart devices. Aha! Your life quality has just been improved because of your indoor air quality enhancement. Now let's look at how the team made the achievement. During the first 5 weeks, the team brainstormed ideas, researched air quality improvement methods, and finalized the project scope with a Gantt chart. During the second half of the last quarter, they established a system flowchart, down-selected hardware, and assembled prototype 1. From week 11 to 15, they focused on enhancing the stability of the system and innovated a shell that fits all components. For the remaining time, the team did various scenarios with a total of more than 50 tests to make the starting point database deliverable and 3D printed the shell, then manufactured the entire product deliverable to Advantech. Yes, this sounds too easy. There must be some challenges to the team. Let's see what they say in the interview.
For me, the most challenging part is to study the idea of IoT from scratch to professional.
The most challenging thing for me is that as a mechanical engineer, I have to learn lots of new knowledge about electrical engineering.
For me, the most challenging part in this project is that I make our services on cloud stable.
At the end, Team XYZ wants to thanks again for the support from Mr. Joe Sanga, Mr. Weilun Huang at Advantech, and the support from Dr. Fazard, and all faculties from the Master of Engineering program and Samuel Alley School of Engineering in UC Irvine. Hope to see you all in the future.